Hi guys, this is 19.4 going over neutralization and titration of acids and bases. Hopefully we'll see how power stays on or not, because you might be able to hear the rain going on right now, but we'll try anyways. Alright, so there's a little clever title for you, Is the Switzerland being neutral and all? Hopefully you learned that in history already. But we're going to start with neutralization reactions. And as always, we're going to start with a joke. Hopefully you get it. Okay. You have a salt over top of a base, so base is under a salt. Anyways, okay. We're going to move on. Neutralization. All right, when you have acids and bases reacting together, and the result is a salt and a water, then you have a neutralization reaction. Here you can see the acids and bases are canceling each other out. You have the hydrogen and the hydroxide resulting in water. Water is mainly going to neutralize our reactions. You have the reaction of a strong acid and a base produce water and salt, like we just said, and then you have an example underneath of that. You've got HCl and NaOH. Those are strong acids and strong bases. Okay, and they're going to cancel each other out to form water and a salt. And that one is actually table salt, but the salts in our acid-base reactions are not always table salt. Okay, they don't even have to have Cl in them, okay, or sodium, but this example does have that. The end result, or the end pH level of a neutralization reaction is 7. Our pH will be 7, and these reactions are exothermic, which hopefully you remember what that means, because you are going to put your answer to that in the box now. Alright, thank you. Moving on. Okay, in our next pictures you can see we have examples of acids and bases. So you have an acidic solution with your hydronium and hydroxide, and you can see equilibrium right there in the middle, and I'll get the little mouse. Right here in the middle is equilibrium, and it has a pH of 7, which is 1 times 10 to the negative 7 molarity. So our pH is in the middle of 7, and for a solution to be acidic, it is going to have a greater than 7 pH, okay? Which is actually, it's just bigger than 10 to the negative 7, and that makes it lower actually in the pH scale, which we'll solve some problems for. Our acidic solution, as you can see here, has more hydronium ions than hydroxide ions, so it's acidic. In the second one, here in the middle, our second red and blue lines, they're equal, so we're in equilibrium. Our reaction pH is neutral, so we're at 7. And then over on the side, our basic solution has more hydroxide ions than hydronium ions, and so it is a basic solution. Alright, for our next slide, I'm going to have you predict some results for me. Okay, so predict the results of our neutralization reactions. So if I have HNO3, okay, and I've got MgO2, what will be my products? Okay, this one we'll do together. Hopefully you're saying water and salt, okay, because we need to have that water. Uh-oh. Power may go out, okay, hang on. Water and salt, and so you're going to have your hydrogen ion and your hydroxide ions form water, and so what is left over? You have nitrate and magnesium. So your salt will be magnesium nitrate. Okay? It's pretty simple, right? A nice double replacement reaction. Hopefully you remember those. But here is our result. And yay! We were right. Make sure that as you're writing your formulas, you don't just write H and O, okay? Make sure you do the correct formulas for these, charges and everything. Because when we get to the end of 19.4, we are going to solve for pH and concentrations and so on. And there went the power, kind of creepy. All right, let's go ahead and move on to our next problem. So you have H2SO4, the 4 should be in subscript, and you have calcium hydroxide. What will be your results here? Okay, take a moment, think about it, and write your answer down for me. Okay, hopefully you put water and calcium sulfate in these correct concentrations. Okay, and then here we have our last one. We've got HCl and COH, hydrochloric acid and potassium hydroxide. What will our products be here? And I'm trying to hurry because power keeps going on and off. All right, write your answer for me. Here's your answer. Hopefully you got it right. We're going to keep going on. This top slide says titration. We've got a little bit of it cut off, so sorry. Okay, titration. This is a way that we can make neutralization reactions occur. Okay, and so it is a method, here's your definition, a method of determining the exact concentration of an acid or base by first getting its volume, figuring out the volume required to neutralize an acid or base of a known concentration. So you start with what you don't know, but you don't know its molarity, but you do know its volume. So maybe you have 1 liter of a solution. Okay, you're going to then add some indicator to it, just a couple drops, and then little by little you add it into a base until the base, and the base you know its molarity and you know its volume. The base, you add in your acid into the base until your solution, the base solution, turns a color. Okay, usually it's going to be a slight pink color, and that's how you know neutralization of the base has occurred. Okay, and this method is used because it's the most accurate, even though it seems kind of old or dated. It is still very useful in making sure that we figure out what our acid or our base is. Okay, you can drop the base into the acid. Okay, and so there you can see an indicator is used to determine when the moles of an acid equals the moles of a base, and moles of a base is behind my head, so sorry. All right, and when you reach that point of neutralization, that is our equivalence point, or the end point of neutralization and our titration method. Okay, kind of like a distillation almost, even. Okay, here is your example. You start with certain milliliters of a base added to your acid. Okay, and we know it's acidic because our pH is down here, and it's going to increase until it changes color, and that change of color represents neutralization. We reached a pH of 7. Okay, and the formula that we will mostly use is, oh, there we go again, M1 times V1, our first molarity and its volume, and that will equal the molarity and volume of our second set. Okay, in our problems that I will show you later on tonight, we'll have problems that deal with more of, the lights keep phasing me out, sorry, but they're going to deal with, sometimes concentrations are not just the M1 V1 equals M2 V2. There are some differences between those two. I'm hoping that the lights on and off are a good way to keep you guys registered into this video, but we'll see. Okay, so here's an example problem for you. I would like you to solve it and put your answer to the side. Okay, how much of 0.1 molars of sodium hydroxide is needed to completely neutralize 100 milliliters of 2.0 molarity of HCl. So sorry. All right, put your answer in. Okay, and hopefully, okay, you have to first solve for your equation. Okay, make sure that it's all balanced, moles, everything, and then you should come up with this format followed by this answer. Okay, it should be 2 liters, or you can have it in milliliters as well. All right. Hopefully this makes sense and you enjoyed this PowerPoint. There will be another one attached to the end just to do a couple more problems for you to master for your test. All right. Have a great evening. I'll see you in a couple minutes, or seconds, I guess, for you.